Hello everyone, welcome to your first official academic day of distance learning. We are going to spend today doing some review for scientific notation. Before we left, we focused on 7.2. We did like 3 days of scientific notation. We multiplied scientific notations together. We divided scientific notations, and we had to take a step back and say, what is one thing from 7.2 that you need to know? And we have decided to do some review. We're going to write an essential question together. Our essential question is, can I convert between scientific and standard notation? Question, because it's an essential question. Please write that down. Oh, I totally forgot. Up in the corner up here, would you please write 7.2? And this is technically day 1. We're not going to have a day 2, but this is a pattern we're going to get in the habit of, so that when we start getting like sheets and sheets of math, we can put them in order and we know exactly what we're looking for if we need to sift back and look for something. What we first need to really identify, though, is what is scientific notation? What does that look like? We spent a little bit of time reviewing it, so let's go over it together. Scientific notation shows really small and really big numbers. It also always has this coefficient, 1.28. I'm just making that up right now. But that coefficient needs to be between, give me a second to think, needs to be between 1 and 10. It can be equal to 1, so greater than or equal to 1, but less than 10. It could be 9.999, but it can't be 10. It needs to be between 1 and 10. We also always have times 10, and that base has to be 10 to any power. So I'm going to say to the power of 6. That 6 up here, I'm going to have you add this to your notes, even if it's familiar, is how many places, I think I used the word spaces too much, but mathematically it's how many places to move the decimal. That is not how many zeros to add, which is a very common mistake. So let's look at how we're going to transfer this over to standard notation. So right now we're in scientific. On the other hand, standard notation is written how you normally found out how to write like 3,200, where it's actually all written out. There's no decimals. And so when we're looking at this number, for example, we're going to move our decimal 6 places. It's just a decision. Are we moving it 6 places to the left or 6 places to the right? And in this case, I know I'm going to move it to the right. I don't like memorizing like positive exponents, go to the right, or like whatever. I just like thinking of positive exponents are bigger, negative exponents are smaller numbers. So because this is a positive exponent and I move my decimal 6 places, if I move it 6 places to the right, I'm going to get a really big number. I'm going to get like 1,280,000. Whereas if I move it to the left, I'm going to get a super small number. So, because if it's a positive exponent, do I want a smaller number or the bigger number? Which one do I want? I want the bigger number. So, I'm just going to do a little bit of work down here, 1.28. I'm going to move the decimal 6 places, 1, 2, 3, 4, 5, 6. And what am I going to do with those spaces? I'm going to add some zeros in there. And my final answer is 1,280,000. So you need to be able to go between scientific and standard. You also need to go from standard to scientific and be able to go both ways. So the next video is going to have 2 or 3 practice problems for you.